Okay, let's take a look at question 21, problem set 6. This is a calorimeter question, coffee cup calorimeter. It says that you started with calorimeter with some water in it at certain temperature, and then you put some potassium bromide inside the coffee cup calorimeter, and after the potassium bromide dissolves, the final temperature now it's only 21.1 degrees. So the temperature of that calorimeter solution is dropped. So the question is, what's the enthalpy change for that process where the potassium bromide dissolves? And you want the answer to be in two different units, joules per gram and kilojoules per mole. All right, let's take a look at how we solve this problem. First, we can draw it just like we've been doing with all the other problems. So we have a calorimeter, which means it's fully insulated, and we have some water in it, 125 grams, 24.2 degrees Celsius. You have some potassium bromide, just 10.5 grams. That's mixed into it. We close it off afterwards, and after potassium bromide placed in there, it dissolves. That's a soluble salt, potassium bromide, so it dissolves. So basically, imagine what you have. You have your ions, right? Because it's a soluble salt. So those guys are floating around. And now that temperature is 21.1 degrees Celsius. So how do we figure out the enthalpy of dissolution, which is when the potassium bromide dissolves, the temperature changes. So that process has a certain enthalpy associated with it. So how do we get that enthalpy? Well, a couple of things. Remember that when you use a coffee cup calorimeter, what you're measuring is the heat that is transferred to the surrounding. Okay, so it's what's happening in the surrounding that you're measuring, not what's happening in the system, because you can't go directly and measure the ions of potassium or bromide. What you can measure is the water that surrounds the potassium bromide. So what you're measuring is the Q of the surroundings. Well, just like any heat, you're going to need to use your heat formula. The most appropriate one would be to use that MC delta T equation. So you have to take the mass of the mixture times the specific heat of the mixture times the change in temperature of the mixture, which is your surrounding in this case. So what's the mixture that's in there? Well, it's water plus potassium bromide. So we're going to add both of them. They tell us to use the specific heat capacity of water, so that's what I'm going to do. And then the delta T is final is this, the initial is that. And if I multiply all this together, you can see that that temperature subtraction gives me a negative number, so it's negative 1755.809 joule. Now, that is your Q of surrounding. What you're looking for is delta H on enthalpy change for the dissolving of the salt, which is for the process itself, for the reaction itself. So that means you're looking for Q of the system. That's what's going to be equal to delta H, right? Because you're measuring this. The reason why it's equal to delta H, of course, is because you're using a coffee cup calorimeter, which is a constant pressure instrument, and heat under constant pressure is called delta H. So that's just going to be equal to the negative of the heat of the surrounding. Since we have negative 1755 for Q surrounding, then Q system or delta H of the system will then be positive 1755, 809 joules. Now that's not the answer, because what they're asking is what's the enthalpy change for the dissolving of the salt in two different units, joules per gram and kilojoules per mole. So what are they asking here? Well, they want the unit to be expressed in joules per gram of the salt itself, which is kBr, and kilojoules per mole of the salt, which is kBr. Right now, this is just how much you use in the experiment. So that amount of heat you get when you dissolve 10.5 grams of kBr. So you can see that immediately if you just do that operation, you get your answer in joules per gram, which ends up being 167.2 joules per gram of kBr. Okay? Now, if you want to take this and convert it to per mole quantity, the only thing you need to do is just use your molar mass, kBr, which happens to be 119 grams per mole, and the grams would cancel. So now you have your answer in moles of kBr. And so that would end up being 19.9 kilojoules per mole of kBr. This is an endothermic process, right? Because the enthalpy change here is positive. Okay? And that makes sense. You notice that temperature of surrounding drops. So this is an endothermic reaction. So it's absorbing heat from the surrounding.